This is table number 1 from the paper. Here we're looking at the influence of crayfish either being in the stream, that's where you see in this table it marked CF, or crayfish being absent from the stream, that would be CF absent. Okay, so we're looking at the top and the bottom rows here, and then our columns in this table are the month that that stream was sampled, and then if there were dragonfly nymphs, dragonfly nymphs here in this table are denoted by DF, and then mosquito larvae by MSQ. Okay, so if you go month by month through this table, we get a sense of if the presence or absence of crayfish influences how many dragonfly nymphs you see or how many mosquito larvae you see. So, looking at March, let's just kind of digest this by itself to start. If you have crayfish, they found in those streams in that month that they only collected 2 mosquito larvae and 2 dragonfly nymphs. Okay? In the streams in March, where there were no crayfish, there were 0 mosquito larvae and 95 dragonfly nymphs, which makes you think that at least in this first month, at least in March, the presence of crayfish will drop or cause a drop in dragonfly nymph number. Okay? When crayfish aren't around, then there's going to be a boost or an increase in dragonfly nymph number. So we don't have to go month by month here, but we can look at the cumulative score, okay, which shows that when there are crayfish around, you have more mosquito larvae and fewer dragonfly nymphs. And then when crayfish are absent, you're going to have almost no mosquito larvae and a lot of dragonfly nymphs. So this is telling us that crayfish have a substantial effect on the ecosystem, specifically the interactions between dragonfly nymphs and mosquito larvae. That was the observational aspect of this experiment, or this paper rather. Next is the experimental aspect, okay, where they ran 72-hour experiments to see if those crayfish or dragonflies being present are going to impact the abundance or the prevalence of mosquito larvae within their own experimental containers. Okay, so this is figure number 2. We're looking at panels A and B here. In panel A, this is just a nice line graph of the number of surviving mosquito larvae over 72 hours. There's a control group just to see how many mosquito larvae die over 72 hours. There's also a treatment with just dragonflies, that's the line at the very bottom, with just crayfish, and then there's another line with the combined treatment, crayfish and dragonfly nymphs. Okay? Now when you introduce either of those predator species or both of them as a treatment, there's going to be a dramatic decrease in mosquito larvae number. But dragonfly nymphs being present by themselves is going to cause the most radical decrease, as you can see here by this lower line, in the number of mosquito larvae. Okay? And if you look at the combined treatment, after 36 hours, the crayfish ate up all of the dragonfly nymphs, so there couldn't be much of a further reduction in mosquito larvae because just the crayfish were doing it. A similar thing is shown in this box plot over here, where we're looking at the proportion of surviving larvae based on the different treatments. Control here, which you have a pretty high proportion of surviving larvae. That's for mosquitoes, that is. You've got next your combined treatment, your crayfish, and your dragonfly nymphs. Okay? Ultimately, what these two figures show us is that dragonfly nymphs are much better at consuming and controlling the mosquito population because they like to eat mosquito larvae. Okay? When you have crayfish by themselves, or crayfish and dragonflies, there's not as much of a reduction in mosquito larvae. Now, hopefully these data together, right, the experimental and the observational data, give you a better idea, an indication of how much of an impact the invasive species of crayfish can have within our local environment. Okay? Well, hopefully this video helps explain a little bit more of the data. If you have any additional questions, please let me know, and have a nice rest of your day.